Welcome back to Math 7 with Mr. Passon. Today we are doing our first proper lesson in Unit 4. We already did a little bit of preview where we talked about operators and operator properties. We're starting to move into algebraic reasoning, so we're going to be talking about expressions. Now, expressions are, well, an expression is a mathematical phrase that can contain variables, numbers, and operations. So in our case, we're going to use letters to represent variables, and those can either be unknown numbers or they can be placeholders for numbers that we want to determine later. Numbers are obviously numbers, and operations like addition, subtraction, multiplication, division, absolute value, exponents, and we'll occasionally talk about other ones. So here we've got our different terms here, and I need to put in another text box. So let's just talk about some of our different terms. I'm going to grab, first of all, I've got my coefficient. That is a number that is multiplied by a variable. So here my -6 is my coefficient. Then this whole thing right here is called a term. So I'm going to underline it. Alright. Then we've got our operation down here. So our variable is our x. Oh, I'm going to undo that. Grab another little arrow. There's our operation. Now we've actually got another operation because we've got a multiplication in there. And then this term that is, and so maybe I'm going to write that operation somewhere else. So we've got two different operations. We've got a multiplication in there and an addition. So one there, and one, there. And then this last term here is called a constant, because it is a term with no variables in it. Okay? Let me get rid of that underlining. I don't like that. So we've got our coefficient, that's the number next to a variable. A variable is our letter. Operations are addition, subtraction, multiplication, and divisions. A constant term is a term that's added or subtracted with no variables. So we've got a term here and a term here. Good. Now, terms can be classified as either like or unlike terms. Now, like terms have certain common features, and we can simplify expressions by combining the like features. Like terms must have the same variable and base. Actually, it's variable and exponent. Alright, so 7x and 9x are like terms because they both have an x. 4d and 4g are not the same term because they don't have the same variable. Alright, so let's look at the like terms here. Well, here this one's got a c and this one's got a c, so we've got our like terms are 8c and -8c. Let's look at this one. We've got our -12x and our 12x. Now, you should try to make your guesses for the rest of this, so go ahead and pause the video here. Go all the way through this one, and then in this one you can determine whether they are like terms or not like terms. Okay, here we've got a w, a z, a Y, a Z, and a W, there are no like terms. Here we've got 11G and negative 7G. This one does not have a G, so our like terms are 11G and our negative 7G. Here we've got T and T, no T, so these two are the like terms, 0.5T and 1.5T. Note that anytime we've got a letter next to a number, that means multiply. Here we've got 1M and M. Here we've got, three like terms. So we've got the 4B, the B, and the 9B. Those are all like terms. These, well, they have the same variable, no variable at all, so they are like. These have the same variable, that's B, so that's like terms. These have the same variable, no variable at all. These, well, we have an R and a P, so these are not like terms. The exponent on the variable is different. Okay, so these are not like terms. Okay, again, the exponent is different. If there is no exponent written, then it's an exponent of 1. And here, all of them have a variable of C, all raised to the same power, 1, so these are like terms. Oh, I missed one down here. So these ones, the constant terms are the like terms, so that's 0 and negative 8. And then here, they are all like terms because they are all constants. Alright, let's go ahead and take a look at page 2. So, only like terms can be combined. And this is actually consistent with everything else that we've done. So if you think about it, like if I said there are 4 oranges and 5 trucks, you can't say there's 9 like oranges. You can't say there's 9 trucks, not orange trucks. You can only add things that have commonalities. And so in our case, a commonality is going to be the variable and the exponent that variable is raised to. Okay. So, the Robinson family ordered snacks at the state fair. They bought the following. D, or drinks is going to stand for, we're going to use a D. Pizza, we're going to stand for P. And ice cream stands for C. Let's write an expression. So let's think about it. How many drinks do they buy? 1, 2, 3. So that's 3D plus pizza stands for P. 1, 2, 3, 4, 5. So plus 5P plus 2C, 2 ice cream cones. Alright. Oh, I guess they wanted us to write it the long way, so this is actually our answer for the next part. So originally we could have written P plus D plus C plus P plus C plus P plus D. Alright, so there's our expression where we've just sort of put everything in order. Now, what we're going to do here is simplify each one of the expressions in here. They're covered up though, so let me fix that. Let me pick the add a new custom color. Let's make it transparent so we can actually see what's behind there. There we go. That's a little bit better. So we can combine. Now, using our properties of operations, we can sort of reverse the order. So we can say this is 7a plus 8a minus 6. And then we can combine our like terms, and that's going to be 15a minus 6. Let's take a look at this one. We can combine these two terms. We can't combine the last terms. So we get 14 banana. Now, a trick that I like is just whenever there's a letter, is make up a word that starts with that letter. So I've got 14 bananas plus 6 bananas minus 12 something else. So I've got 20 bananas minus 12 something else. Alright. Here I can again sort of reverse the order to think about the C's together. So I've got 20C plus another 10C. So that's going to be 30C. And then plus 8 minus 5D. So that's plus 3D. Alright. Now, take a break. Stop the video. Finish the rest of these. And then we're going to talk about the rest. Okay, so let's take a look at this one. They're all D terms. We've got negative 3 plus 8 minus 5. That's 0D, so that's just 0. Everything canceled out there. We've got 3 minus 7, so that's going to be negative 4. Negative 4E, and then we've got negative 19 plus 10, so that's going to be minus 9. Notice how we're using our other properties of operations to switch the order of things. Here we've got negative 4F minus F, so that's negative 5F. And then we've got minus 9 plus 15, that's going to be plus 6. Okay, let's look at our last row. We've got 1.5G plus 6.5G, that's 8G. And then minus 10 minus 3, that's minus 13. Here we've got a half plus 2 plus 3 halves. So that's 4H. And then we've got minus 1. Oh. Notice that we cannot combine those terms because this has a variable and this one doesn't. Let's look at our J's. We've got 4.2 plus 6.7 minus 5. All of them have J's. That's going to be 5.9J minus 5. Now, go ahead and summarize what you learned today. What's the key points for understanding like terms, unlike terms? Think about when you might start using these expressions when we have forms that are complicated enough that we would need something like this. Excellent work. Go ahead and look at the assignment in Alex. Okay, so once you finish here, look at your assignment in Alex. Have a good day.